Cool. So let me start with our slides and we'll get chatting about our lab today. So this is a bit of a beefy lab, and we're just going to lay down a few concepts that you should have learned in the lecture section before we get started with the actual lab content. So we're going to be analyzing angular kinematics of a vertical jump. We need to know angular position just as a concept and how everything is kind of relative. So this is a common theme throughout our class, kind of like how when we analyze the cannonball, we were thinking about specific forces acting on the cannonball. When I ask you specifically about the vertical horizontal or vertical acceleration or the horizontal acceleration, everything is relative to those specific forces. So for now, everything is going to be relative to either the joint angles or the joint segments or the joint planes. So right here, we have a measurement relative to joint segments. As you see, we are measuring the knee angle, and it's relative to our hip as well as our ankle. That's what gives us that angle. However, that's not the only way to do it. We could have a transverse plane going across the body and measure relative to that. And that would give us a different measurement because we're measuring against a different standard. Does that make sense so far? An angular position is denoted as theta, which is this kind of circle with that weird line through it. Next thing for angular position is how it's measured. So here we have it measured in degrees. However, it could be measured in revolutions as well as radians. So radians we'll touch on later in the class, probably more in the lecture section than our lab. Revolutions refers to just full rotations of the circle, so full 360-degree rotations. These measurements are common in cyclic motions, such as bicycle riding or running, where you have a constant motion and you're looking at that repetition. For this lab, though, we will mainly be analyzing things in degrees, such as this image right here. Next, we'll talk about angular velocity. So this is denoted as omega equals delta theta divided by delta t. And I know this is intimidating and this is a handful, but this is just the same as our other velocity equation. It's written out right here as angular velocity, which is that W right there, or omega, equals the change in the delta, the theta, which is the angular position, divided by the change in time, which is delta t. And just a quick refresher, it's always going to be final minus initial when we're dealing with those deltas. So we want the final time minus the initial time, or the final angular position minus the initial angular position. Does anyone have any questions on this so far? Excellent. So like I was telling Tristan and Jackson earlier, this lab is a little beefy. If it was me, I probably would have done this lab last week. But you do get 2 weeks to complete it, which is the good part. I am going to encourage you guys to try and get this lab done soon, just because it's just so much information I'm going to dump on you with Tracker and Excel right now, that while it's fresh in your mind, it'll be easier to complete. So first off, I'm going to show us the lab activity. So what you're going to be doing is doing an experiment just like this right here. You're going to be putting markers on a subject. This subject can be yourself. If you want to set like your laptop on like a kitchen chair and have it face a wall, just make sure it is nice and even. You want a marker on the shoulder. You want a marker on the hip, a marker on the knee, on the ankle, as well as the toe. The joints we're going to analyze are going to be the ankle joint, the knee joint, and the hip joint. However, you do need these other markers on the outside, and we'll discuss that in a little bit. So you're going to ask your subject to perform a maximal jump, just stationary, no arm swing, just from standing there to jump. After you do that, we're going to go ahead and open that up in Tracker. So just a little refresher for Tracker. How we do that is go ahead and hit File, go to Imports, Video. We navigate to our video and we get to open that up. Next thing you do is see our video is kind of sideways here. So we could remedy that by go ahead and going to Video, applying a filter, a new filter. Then we could rotate this video 90 degrees to make it the proper orientation. Everyone got that so far? This is going to be quite a bit, so I encourage you to take notes. Next thing we're going to do is we're going to trim our video down, because if I go ahead and play it through, you see we got all this time right here where she's just standing around. She goes ahead and jumps. That's what we're interested in. Then we got all this time on the end that we don't really care about. So we're going to have two indications of key onset of movement. The first one is going to be right when the shoulder starts to move. So I will play the video from the beginning again, keeping a watch on that shoulder. And as soon as it starts to twitch, right there, we saw a little twitch in the shoulder. We want to mark that as the beginning of our video. So I will go frame by frame and find the beginning of exactly where shoulder starts to move. So it looks like right there. It's the first frame. There's a little twitch you can barely see. So that's the key indication of the start of the movement. So once you find that start of the movement, I'll have it noted as frame 14. You want to go back 3 frames, and this just gives you a little wiggle room for your analysis. So we don't want to start immediately on the points we want to analyze. So go back 3 frames, brings me to frame 11, as shown down here. And then I will drag this black tab right over to frame 11. Now I'll do the exact same thing on the other half of the video, except this time I am looking for the moment that she leaves the ground, or the last frame where her toes are on the ground. So if I play the video, I can pause there and I can go frame by frame again. I see her toes are off the ground there, on the ground there. And from here, we want to go 3 frames out one more time, just so we have a little bit of wiggle room to work with. And again, I can grab this black tab right here, our end frame, and drag it. Oops, don't remember the frame number, my bad. It's frame number 46, so 3 ahead of that, 47, 48, 49. So frame 49 is what I want to drag it to. And that just trims a ton of length off my video, all of these frames over here, and all of these frames on the end, because I only want to analyze what's between these 2 black bars. Everyone got that so far? Any questions? Cool. Next thing we want to do is we want to establish our frame of reference, or calibration stick. We want to calibrate Tracker to what a meter is. So Tracker doesn't know that we're looking at a girl standing in front of a door right now. For all Tracker knows, this could be a landscape photo. So Tracker does not know how long a meter is in reference to this picture. So we could tell Tracker that in the lab, it had you measure your subject's shank length. So the shank is going to be from the knee down to the ankle. And I measured my subject shank at 39 centimeters. So I can make a calibration stick doing that. And I go to Track, New, Calibration Tools, and Calibration Stick. I go ahead and zoom in on the shank. I hold Shift to bring up the crosshair. I go ahead and click on that marker. And again, I'll hold Shift again and click on the other marker. So that's going to bring up a line, and that line is saying 336.4 meters. Obviously, we know it's not 336.4 meters. That's almost a quarter of a mile. So we could then label that with our known value. So like I said, I measured her shank at 39 centimeters or 0.39 meters. Any questions? Cool. I'll go ahead and click calibration stick, make it invisible, just because we don't need to bother with it anymore. Next thing we're going to do is we're going to start tracking these actual markers. So we're going to establish points of mass. So if I then go up to this toolbar again, I click create, I can create a point of mass or point mass. I'll go ahead and name it. I'll say this one's the ankle. We'll do the ankle for this example. Once we name it, we can go to our ankle marker. And the best way to mark this is you want to do kind of the edge of the marker, because how Tracker works is it identifies RGB values. So if you have a contrasting area with like the black and the white or whatever color you use, it's going to help Tracker identify it easier. So in order to make that mark, we hit Control Shift, or I believe if you're on a Mac, it's Command. Can someone confirm that for me? Anyone got a Mac?
Yeah, it's Command.
Command Shift, or yeah, Command Shift then. And you'll be able to bring up that crosshair, and you want to click on that that point in between. You see this template here. This is where I clicked. That's where our marker is, and that is what Tracker is going to look for throughout this video. So after that, I'm going to click Search Next, and this is just basically going to the next frame, and Tracker is going to be searching that frame for this point of reference. So it goes forward, and the ankle doesn't move much for a lot of these early frames, so it kind of goes on top of itself. But if I continue going and I click kind of quickly, you can see Tracker tracking that movement, especially with that knee and hip flexion. Ankle starts to move. Then right here is where we start picking up speed. Like I said, you can click through these fairly quickly, but you want to be sure Tracker's on the right spot on each frame, or else it will affect your data. So here's where it gets a little tricky. See, I keep clicking. She's going kind of faster, so it's getting blurry. And right there, Tracker loses our marker. So from this point, I find it easiest just to manually enter in the markers. So how you do that is you hold Shift and just put the crosshair where you think the marker is. Good estimation is all I ask for. It's not going to be perfect, but it will be good enough. So I think the marker is right about here. So I'll hold Shift, and I'll click it. It's going to move me to the next frame. Hold Shift again, click where I think the marker is at. I'll do this for a few more frames until we finish right here at frame 38, or 41, but 38 in our reference. So I can go ahead and close that. And you will do that for each body segment. So you do that for the shoulder, you'll do that for the hip, do that for the knee, the ankle, and the toe. Questions so far?
Where did you go to add the point of mass?
For sure, you go up here to create, and you just click point of mass or point mass.
Awesome, thank you.
No problem. That'll bring up your point masses right here, and you could click on them, and then you'll have the ability to name them as well as make them visible or invisible. If it gets too messy on the screen, just go ahead and make them invisible. You can bring them back anytime just by re-clicking that. Next thing we're going to do is I'm going to skip ahead. I'm going to open up a file that already has all those points of mass identified. Just to give you guys a visual of what that looks like, I'll play that forward for you. You can just see Tracker looking at all those movements and bringing up our data right here on the right side. Next thing we're going to do is we're going to use our protractor tool and start measuring our joint angles. For this example, I will do the knee. So we will go ahead and go back up to create, and we will go down to measuring tool, and we will use the protractor. So that's going to throw a protractor on the screen. And what we're going to do is then attach this protractor to those tracking markers that we just calibrated. So the vertex of the protractor, or the center of the protractor, is always going to be on the joint that you want to analyze. So like I said, we want to analyze the knee. So I will attach that to the knee. What you do is you right click the protractor, click attach points. Vertex goes right on the knee. And then the arm and the base go either above or below the joint you want to analyze. It doesn't matter which one's above or which one's below, just as long as one's above and one's below. So I'll put the arm on the hip, and I'll put the base on the ankle. This is why you had to go one more marker outside of what we're analyzing, just because you need to attach that arm or base one farther down. So if you're analyzing the ankle, you want the vertex on the ankle, you want the arm or base on the toe, and then the other arm or base on the knee. Rename it. I'll go ahead and rename this to knee angle, just for convenience sake. I'll play it through just so we get that visual. We see it starts with measuring on this side and then flips to the other side. We don't want that. We do want all on the back side of the knee. You can see it's going to flip again right there. So we need to do some calculations to account for that. And just a little bit of background info. If you measure an angle in the clockwise direction, it's going to give you a negative value. If you measure an angle in the counterclockwise direction, it gives you a positive value. So that's why it's showing us a negative 172.8, because it's measuring in the clockwise direction, and it's 172.8 degrees. So we want to take this data from this knee angle. We're going to grab it all right here. We're going to go ahead and copy it. And then we're going to dump that data into Excel. Everyone seeing Excel? Is that on our screens? Cool. So we see our data going, and we see that it's in all these exponentials that you'd see in like a chemistry class, and we don't want this. We want simple numbers. So in order to remedy this, we can go ahead and highlight our data. Right click, format cells. And after we get into format cells, we can go up here to number, and it has this first number right here. We can go ahead and click OK. And that puts these all into just simple numbers. So just to run through that one more time, you highlight your data, right click, format cells, number, first number, OK. Next thing is, like we were talking about earlier, we want to analyze the backside of the knee. We want those knee angles. And for the first part of the tracker, we had all of these numbers on the front side of the knee. Tristan, do you have a question?
So did you just order them from like least to greatest?
No. So they are attached to their time from the, what do you call that? From the tracking software. So let me show you. So 172.8 is our first data point, negative 172.8, because it is attached to our first frame. And so it's just going to be all of these numbers right here listed out all the way down that data sheet, attached with their frame numbers or their time. Does that make sense?
Yes.
Cool. So each frame is 0.03 of a second, and that's why it's denoted like this. And like I was saying, we are on the opposite side right here. So we want to flip this around. Someone have a question? Oh. Cool. So we want to flip this around and we make it a positive number because we're going to be analyzing it in the counterclockwise direction. So in order to do that, we do some cool Excel formulas. We go to the next column over, press equals. We'll do 360. Oops, not 1 through 60. $360 for the 360 degrees in a circle. We're going to subtract the ABS, or the absolute value, of this number right here. And so that's just telling Excel to give it a positive value and subtract it down, and that gives us our value on the other side of the circle. So that gives us 187.17. So just to put a visual to that 187, that is the opposite side of this circle. So that is measuring this angle right here, which is what we're looking for. So like I said, we're on the negative side and the right side, and then we flip over to the left side, which is what we want halfway through the movement. And this is going to vary with your data. You are going to probably need to experiment, and I am going to be available to look over your data. And this is why I am encouraging you to do this as soon as possible, so we don't leave it to the last minute. We got 2 weeks to do it. So I know it sounds like a lot of time, and I know people like to wait till the last minute. I've been there. I totally get it. But this will benefit you doing it early. So now that we have that equation right there, we can go ahead and click on this corner box right here and pull it down to all of our negative numbers. And that's going to give us that equation applied to all of these cells.
Can you redo the data again?
Can you say that one more time? The
I said,
equation?
can you redo the equation for this to get them to positive?
Sure, yeah. I'll do that right down here, because down here we also flip to the other side and we need to adjust this data as well. So what we do is equal sign 360, and that 360 is the entire circle. So we're just subtracting that other half of the circle because we want the half that we want to deal with. So minus ABS, absolute value. Do a parenthesis. We click on the cell that we want to subtract. Close that parenthesis, hit enter, and that is the data we're looking for. And drag that down. So right here we could see it equals 360 minus ABS, parenthesis, and then you click on the cell that you're looking for. And just to pull the data over, cool. So this is our revised data. So this is our raw data, our raw angular position, and this is our revised angular position for the positions that we're looking for. I'll give you an example of why we do this. If we just go ahead and graph this data right here, we always want to do the smooth scatter plot. We get this funky looking line from it flipping sides. But if we graph this data right here, get this nice line that accurately describes our knee angle throughout the movement. Cool. So I will show you the example of the graphs that we're looking for. These are on your lab sheet. So we have our lab right here, and down here at the bottom, we have examples of our graphs. Like I said, you're going to be analyzing 3 different joint angles. So you're going to have one for the knee, you're going to have one for the ankle, you're going to have one for the hip. So this is all of those. They should be labeled. But you're also going to need to label the onset of the movement, which we talked about before, is right when that shoulder starts to move. The takeoff, which is that last frame where the toes are on the ground. and then the lowest point of movement, which is the point where the hips are the lowest in the video. So we can look at that real quick. So we try and find the point where the hips are the absolute lowest. So I could click through the frames. It's kind of going up there, going down, probably right around there, frame 36. I could tell because it's the spot where the knee is at 98.9 degrees. So I can go over to my Excel book, find the spot with my knee at 98.9 degrees. So I know at 0.83 seconds, that's going to be where my my lowest point is. And you see we have some funky XAV values for our data right here. And we could remedy that. Right-clicking, go ahead and select our data. So this series 1 is this series right here, the series of data. If we edit that, we could assign a series of X values, which we just drag here, hit enter, hit OK, hit OK, and that gives us our proper X values. Cool. So that's the chart so far. In order to mark those onset, lowest, and takeoff points, all you got to do is insert a line. So you go to shapes, insert line. I'll say 1.2 is going to be my my takeoff. So I just got to draw a line straight down. It's kind of blue and light, so I'll change that line to black, and I'll change the outline weight into like 2.25 point. Then I can just insert a text box. And label that takeoff. You could do 6 graphs if you want, or you could do 2 graphs. You could do 1 graph for each joint, or you could put them all on the same graph. It's up to you. We do have to also We do also have to analyze angular velocity. So this graph denotes angular position. In order to get angular velocity, which we discussed in our little tiny lecture, let me find that, is that angular velocity is going to be the change in angular position divided by the change in time. So just like our regular velocity equation. So if we go back to our Excel book, we have our angular position right here. We have our time. We just need to do our final minus initial and solve for it. So we go to the next slide over. I will label this as angular velocity. We'll do a little bit of Excel magic to make it appear. So we're going to do another equation, equal sign, absolute value. We're going to go ahead and have 2 sets of parentheses here. Then we're going to go ahead and do our final angular position minus our initial angular position, close that set of parentheses, divided by our final time, more set, final time minus our initial time. And we'll close that set of parentheses, close the absolute value parentheses, hit enter, and that gives us our value. All we got to do is pull down that corner, and that gives us all of our data. So each time we pull it down, that's basically telling it to do the same equation on the next set of data down. So again, I'll do that one more time since I know it's a funky equation. Do equal sign, ABS, 2 parentheses, and we want our final minus our initial for our angular position. Like I said, our final angular position here, because we're looking for the change in these two, it's going to be right there. minus our initial, close this set of parentheses, divided by another set of parentheses, our final time minus our initial time. Then we'll just close up all our parentheses. Questions so far? Sweet. So you'll do the same thing. You'll graph this data. Something a little bit like this. If it looks too far off from the example data, you've probably done something wrong and gone wrong. And we'll just need to analyze your data and make sure everything's all good before you move on. These data sets right here in the lab activity are great examples. You just want to make sure it follows this general pattern. Okay, I know it's a lot. How are we feeling?
What needs to be the x values for angular velocity chart?
It would be the same thing, the same time. So we do the same thing. We right click it and select our data, our series 1, edit, then we would assign our series x values. And that goes ahead and changes it to our time. Like I said earlier, I encourage you to work on this early. It's fresh in your brain. I hope you took notes. We do have YouTube videos on our lab page that I recorded. I have brand new respect for content creators because I didn't think it was that hard to string together some videos. I spent like 4 hours on the 15-minute videos. It's crazy. Other than that, any other questions?
Will this lecture be posted?
I could post it if you'd like. Definitely. For sure.
Yeah, that'll be helpful.
Cool. Yeah, I will do that. I'm not going to make you guys hang out in breakout rooms just because you guys need to go out, you need to get your subjects or be your own subjects and make markers and kind of do the stuff. I do recommend that you wear contrasting colors to make it easier for tracker. But if a black Sharpie is all you got, a black Sharpie is all you got. Any other questions before we head out?
Do we have to use tracker?
Yes, I don't, unless you have another way to get that data. There is Canovia. I'm not as experienced in Canovia as Tracker though, so I will not be able to help you unless you use Tracker, if that makes sense. Same goes for if you want to use Google Sheets instead of Excel. You're more than welcome to do so if you could produce the product of those graphs. It's just I'm not experienced with Google Sheets, so I don't know how to help you if you run into issues. Does that make sense? Cool. So on our lab page, we have the lab posted, we have the YouTube videos, we have the lecture slides, and I will put this lecture video up as soon as I can. Last opportunity for questions before we head out. Cool, this is available. I encourage you to do it as quickly as possible. I will be available during spring break, so just send me an email and I can look over your data if you'd like. Other than that, have an excellent day, excellent spring break, and I will see you guys in 2 weeks.
Thanks, Connor.
You, Connor.
Yeah,
All right, thanks, Connor.
Thank you.
no problem.
Thank you.
Have a good one.
Connor, could you pass me the, because I know you sent the tracker link. Could you possibly send it to me again to download it?
It might be in lab 1's folder. Let me double check.
Is it? Let me check.
or lab 2, I should say.
Lab 2. Yeah, it is.
Okay. Is that okay if you just use that link?
Yeah.
Sweet.
All right.
No problem. Have an excellent day.